Welcome to the session on moments, equilibrium. The objectives for this session are to solve problems which involve rods in equilibrium. Recall that the clockwise moment of F about the point P equals mod F times d when the distance is perpendicular to the direction of the force. When the perpendicular distance is not given, we need to calculate it using trigonometry. In the example shown on your screen, we have that the clockwise moment of F about P equals mod F times d sine theta. A rigid body is in equilibrium when the resultant force in any direction is 0 newtons and the resultant moment about any point is 0 Newton meters. If the resultant moment is equal to 0, then the sum of the clockwise moments equals the sum of the anti-clockwise moments. Many problems involving rigid bodies can be simplified by choosing which points or which point to take moments about. This will allow you to ignore rotational effect of forces acting at that point. Let's take a look at an example. Consider the diagram of the uniform rod AB with length 5 meters and weight 15 newtons. The rod is resting horizontally on supports at C and B, where CB equals 4 meters. Calculate the reaction of each of the supports. So let's solve this. We begin by considering the diagram and adding more details to it. The weight is 15 newtons. The weight of the rod acts at its midpoint as this is a uniform rod. We are required to calculate the reaction of each of the supports. These are shown in the diagrams, RC and RB. It is preferable to take moments about the point which makes the algebra more simple. In this example, taking moments about B gives an equation in one unknown. As the rod is in equilibrium, RC plus RB equals 15, as shown. Now let's consider the moments about the point B. Fifteen times 2.5 equals RC times 1.5 plus 2.5. And then solving for RC gives us that RC equals 9.375 newtons. If we now substitute this into RC plus RB equals 15, we have that RB equals 5.625 newtons. Now let's take a look at another example. A uniform beam AD with length 10 meters and weight 50 kilograms is resting horizontally on supports at B and C, where AB equals CD equals 2 meters. When a workman of mass 90 kilograms stands on the beam at X, the reaction at C has magnitude 3 times the magnitude of the reaction at B. Model the beam as a rod and model the man as a particle to find the distance AX, as shown in the diagram. Now let's consider the diagram and add some more details to it. Since the length of the beam is 10 meters and AB equals CD equals 2 meters, we have that the length of BC is equal to 6 meters. The weight is equal to 50 kilograms. So therefore, the weight of the rod acts at its midpoint since this is a uniform rod, as shown. Notice that since force equals mass times acceleration, and as the mass of the beam is 50 kilograms and the acceleration due to gravity is given by g, we have that the force equals 50 g newtons. The reaction at C has magnitude 3 times the magnitude of the reaction at B, and this is given as shown. The workman stands at X, and since his weight is 90 kg, the force acting at the point X is 90 g newtons. Now, since force equals mass times acceleration, and as the mass of the workman is 90 kg, and acceleration due to gravity is given by g, we have that the force acting at X is equal to 90 g newtons, as shown in the diagram. So now if we resolve vertically, we have that RB plus 3RB equals 50G plus 90G. And so we have that 4RB equals 140G, which implies that RB equals 35G. So the force acting at C equals 3 times 35G, which equals 105G, as shown in the diagram. Suppose that the distance from A to X is equal to X meters, as shown. If we take moments about A, we have, and notice that the rod is in equilibrium, so the clockwise and the anti-clockwise moments are equal. So taking moments about A gives us 50G times 5 plus 90G times X equals 35G times 2 plus 105G times 8. These, of course, are the anti-clockwise moments. So the anti-clockwise moments, we have 35G times 2 plus 105G times 2 plus 3, as shown. And this equals 50G times 2 plus 3. Plus 90G times X. And then tidying up gives us 910G equals 250G plus 90GX. And tidying up gives us X equals 7.33 meters. This brings us to the end of this session. If you have understood its contents, you should be able to solve problems which involve rods in equilibrium. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.